In this video, we'll demonstrate the correlation procedure in SPSS. This is a file of data on a sample of 406 automobiles with the following data recorded for each car: the miles per gallon, the engine displacement measured in cubic inches, the horsepower of each car's engine, the weight of each car measured in pounds, the acceleration of each car measured as the time taken to accelerate from 0 to 60, the year the car was manufactured, the country of origin in which the car was manufactured, and the number of cylinders in the car's engine. In order to run the correlation command, each of the variables to be correlated must be measured at an interval or scale level of measurement. In this particular file, all the variables are measured at the interval scale level with the exception of the origin. This is a nominal variable. Therefore, we could correlate every variable with every other variable in this file. What we will do is we will correlate the first 4 variables, that is, the miles per gallon, the engine displacement, the horsepower, and the weight of the cars. We want to investigate how these variables may be related to each other. To be somewhat more precise, we'd like to see how the variation in each of these 4 variables is related to the variation in the other variables. We begin on the command line with the Analyze command. We click, and on the pull-down menu, we scroll down to Correlate. On the Correlate menu, there is a second submenu, and the choice we wish to make here is bivariate. We want to correlate 2 variables at a time. We move the variables to be correlated from the left to the right panel. The program will correlate the Pearson correlation coefficient for us. These other parts of this display will be explained in a subsequent unit. Having chosen the variables to be correlated, we click OK, and the outcome is called a correlation matrix. What we have done is we have correlated each of the 4 variables with the other variables. So this is the correlation of miles per gallon with engine displacement. This is the correlation of miles per gallon with horsepower. This is the correlation of miles per gallon with vehicle weight. I'm going to switch screens for a moment to explain the structure of this correlation matrix somewhat more clearly. This is a color-coded variation on the correlation matrix. Notice that the numbers in the 2 red cells are the same. That is because in this cell on the top row, this is correlating miles per gallon with engine displacement. In this second row, this is correlating engine displacement with miles per gallon. These are the same 2 variables, and so the correlations between them are the same. Similarly, this is the correlation of miles per gallon with horsepower. This is the correlation of horsepower with miles per gallon. Again, these are the same variables, and so the correlations are the same. This is the correlation of miles per gallon with vehicle weight. This is the correlation of vehicle weight with miles per gallon. You can see the way these cells are coded, that the cells that have the same colors are the same variables, the same correlation coefficients. Running down the diagonal of this correlation matrix from the top left cell down to the bottom right cell, you'll notice that every correlation coefficient is 1. That is, there is perfect positive correlation between the variables along this diagonal, and that's simply explained. This is the correlation of miles per gallon with miles per gallon. In other words, the correlation of one variable with itself. This is the correlation of engine displacement with engine displacement, the correlation of horsepower with horsepower, the correlation of vehicle weight with vehicle weight. In all 4 instances, the variables are being correlated with themselves. This is a definition of perfect positive correlation reflected in Pearson correlation coefficients of +1. We can also point out that the correlations in the cells to the right and above the diagonal are the mirror image of the correlations to the left and below the diagonal. Once we know one set of correlation coefficients, we automatically know the other set of correlation coefficients. Now, what this particular correlation matrix is telling us is that engine displacement is negatively associated with miles per gallon. As the engine gets larger, the miles per gallon gets smaller. Horsepower, negatively associated with miles per gallon. Vehicle weight, negatively associated with miles per gallon. On the other hand, engine displacement is positively correlated with horsepower. Larger engines generate more horsepower. Likewise, engine displacement is positively correlated with vehicle weight. Heavier cars generally require larger engines to power them. Similarly, vehicle weight and horsepower are positively correlated. Now, what we see in these cells to the right of and above the diagonal are exactly the same as the correlations to the left and below the diagonal. This structure of the correlation matrix will always be the same for all SPSS correlation output. You may recall that in the original output, the cells in the correlation matrix were not color-coded, but the structure of the matrix itself remains the same. The color coding was done to highlight the nature of the structure. Okay, that's correlation, and we will take a look at the interpretation of some of the other data in the correlation matrix in a subsequent unit.